This meme right here explains 50% of what AI agents do. Okay, maybe not 50%, but they explained quite a lot, and we'll take a look at that in a second. But for now, let's look at some definitions.
AI agents are software systems that use AI to pursue goals and complete tasks on behalf of users. They show reasoning, planning, and memory, and have a level of autonomy to make decisions, learn, and adapt. AI agents are advanced AI systems designed to autonomously reason, plan, and execute complex tasks based on high-level goals. An AI system that has instructions what it should do, guardrails what it should not do, and access to tools what it can do to take action on the user's behalf.
Okay, they're main definitions, but what are some of the common themes here? Let's take a look. They're autonomous. They plan. They take action. They adapt. They complete tasks on behalf of the user. But how do they work? Let's get back to the meme and take a look. Here we are. The agentic AI economy is resting on reasoning LLMs, large language models, which are resting on a prompt which says,
"Please, bro, respond to valid JSON format without errors and make sure the syntax is super correct. I'm begging you, man."
The key word here is JSON. We have to understand what JSON is and does to understand what AI agents do. So let's go to ChatGPT, ask it to create a normal response first, and then to create JSON, and you'll see the difference and see what JSON looks like. Now we're in ChatGPT, and let's ask it something silly like, who would win in a battle between a lion and a tiger? So we got a longish response, and it's not very clear right away who the winner is. If we feed this into a program, the program will be confused. So let's ask it differently. Who would win in a battle between a lion and a tiger? Respond in JSON. Include winner, justification, and a confidence score from 1 to 10. Now we get something completely different. We see an unambiguous winner, the tiger, we get a justification, and we get a confidence score. And that is JSON. It's a notation to structured data, traditionally for web applications. It is surrounded by these curly brackets and has those key value pairs like winner and tiger. Now that we have an idea of what JSON is, how does JSON fit in? Well, let's backtrack a little bit. When we talk about AI agents, we're talking about software programs. Software programs have functionality. They do something. In code, that functionality would be done through functions. Say, in an email application, we could have a function like search email or send email. To be able to use these functions, we typically need to provide some inputs. Things like keywords for search email or text and recipient for send email. In the typical email application, these functions are invoked when we click a search button or send. These functions expect very specific inputs to be able to be executed and do something. So let's say instead of us clicking the buttons, an LLM decides they want to search emails or send an email. They need to provide the name of the function and the required inputs accurately. So if the LLM provides a JSON, the next thing the program can do is extract that info from the JSON. Those must be correct, otherwise the machine will reject it and won't do anything. So that's what the meme refers to. Okay, so LLMs produce a JSON, but how do the LLMs work within the program? Let's review 3 things. First, LLMs are embedded in functions. Typically, the LLM itself will be put in a function that will be made part of a workflow. When you type a message in an AI chatbot, this would trigger that workflow. Within that function, we would make an API call to an LLM provider like OpenAI or Anthropic, or connect to our own locally hosted LLM. Second, LLMs are goldfish. When we use the OpenAIs, Anthropics, or any API, know that they're stateless, meaning they don't really remember what was asked before. They are like goldfish, very clever goldfish, but still. So we need to make sure our prompt has all the information each time we make a request to the LLM. Third, prompts are dynamically constructed. When we define the prompt for an agent LLM, we create something like a template. Why? Well, because when we write the prompt, we don't yet have all the information. Some of it will be known during runtime, i.e. when the program runs. The user requests an example of a dynamically injected element. So when we define that template, we would mix the static, hard-coded instructions with placeholders of where the dynamically included information will go. Let's build upon our understanding of the prompt next. We start with the system prompt. This typically has the role, persona, high-level goal of the LLM agent and rules. In the React agent, where React stands for reasoning and acting, the instruction could be something like reason through what the steps are to fulfill the user's request and choose the correct tools until the job is done. React is based on this now ancient paper from 2022, which you can check out if you're interested. After the system prompt, we have the user request as we discussed previously, which is done through a dynamic placeholder. Similar with previous chat messages, they go with a placeholder. They're only relevant if we are dealing with a chatbot. Then we have the tools descriptions, which are basically descriptions of the functions and what inputs they need to be executed. Typically those descriptions will be static, but if we have hundreds of tools, there is a way to dynamically select which tools are relevant for the job and dynamically include only those that apply. We would also dynamically inject all the results from previous tool calls. This will allow the agent LLM to review new information and reason through what tools to call next. The React agent we mentioned earlier would continue doing this over and over again in a loop, and the new results will get included in the prompt each time the tool gets executed. The next part of the prompt is examples, which, as we know, is a fundamental part of any good prompt. These are typically hard-coded, but they can be dynamic as well. For instance, my last chatbot had access to a database with examples, which will be dynamically injected based on semantic similarity to the query. Then we may repeat the most important parts of the prompt, as LLMs have shown to pay most attention to the beginning and the end of the prompt. Did you notice something? We didn't mention anything about JSON or structured output requirement in the prompt. In reality, what happens is that we define a schema for the structured output. We provide that schema alongside the prompt in the API call, and the different providers are responsible for providing us the JSON. Anthropic does that by simply updating the prompt before sending it to Claude, and Claude is trained so extensively at producing JSON that it does so reliably. OpenAI has a very cool way of doing it. They don't even update the prompt. They use a technique called constrained decoding, which forces the model to produce JSON natively. Alright, I hope this sheds some light on how AI agents work. Now you may see why it's challenging to build good AI agent systems. LLMs hallucinate, but that's not the only issue. The dynamic nature of the prompt constructions for agents means that we may not fully know what the prompt may look like at any point of time. So we need to think about how to manage that context for them, the so-called context engineering. And bear in mind that agents are typically wired together in some configuration like a crew or a hierarchy of supervisor and worker agents. So for each of those agents, we need to think about what information they're getting, ensuring that it's not too much or too little information, otherwise results will suffer. Garbage in, garbage out, as they say. On top of that, the usual requirements for software systems apply. Things like security, reliability, performance. You may see why it's so difficult to build good AI production systems. On that cheery note, thanks for watching and see you next time.